Good morning. Good morning, everyone, and thank you for joining us here. I'm Dean Tribble, CEO, as Roland said, and I'm going to talk to you about governance in general and governance on the Agoric system and pluggable governance for DeFi. So first, questions. Please take your questions to YouTube live. I'll be able to see those quickly, or go to Discord. If you haven't signed up for Discord, absolutely please go there and post your questions there. I know there's a long tail of people watching this in the future. We will be happy to talk to you about this anytime you bring questions to us. So I look forward to seeing your comments and questions. Okay, so first, our agenda. Let's vote. Everyone who wants to hear about governance, please raise your hand. Okay, I guess that doesn't really work in this context. I will pretend you all voted. The nice thing is I'm going to do my agenda whether you voted or not. So we'll introduce some concepts on governance and about Agoric, look at some code samples, and then come back and wrap up on how all of those pull together. And then hopefully you'll go off and build pieces that build applications in the hackathon that use this stuff. Okay. Now, aren't you glad you voted because you got the agenda you were looking for, right? So what is governance? The act or process of governing, well, a little recursive, or overseeing the control or direction of something. Thank you, Merriam-Webster. What does it mean in our context, or why do we do governance? Well, as it said, first is to oversee and control the direction of execution of some smart contract or DeFi on the system. But there are other reasons as well. Learn the sentiment of the participants. One of the things that the Cosmos ecosystem, for example, has is it has very rich governance that measures that sentiment before the validators go off and do what the validators are going to do, but guided by that sentiment. That means they can, they can look at things and go, yeah, wow, yes, there's 51%, but we should do better than merely 51%. We should have 80% of the people really excited about the change we're about to make. Let's keep thinking, right? Learning that sentiment is hugely valuable. Generally, that's a social thing, not something that shows up on smart contracts. Or signal virtues to the customer, right? I mean, you were happy that I asked for a vote at the beginning, right? I mean, work there. That turns out to actually be important because it's a part of engagement and it relates to that learning the sentiment or giving people some hand in control. That is a virtue, and having the explicit and visible governance signals that to the world and helps them understand where you fit in their overall scheme of things. And then finally, all of that leads to increasing the engagement with the community. Those are all valuable. The important thing is governance long predates blockchain, and it's valuable to not sort of always reinvent the wheel there, but actually tap into some of the long history. Well, 1656, that was a few years ago. 1689, still older than me, right? And some of them not so friendly, but important to governance. So there's a lot of these things. Whether it is how do you do a democracy, or what were the corporate governance failures in the Enron scandal, or what in the Prince are people likely to do that you really don't want to have. All of these things. Hayek was a big inspiration to our large-scale economic model and how we compose large-scale systems out of small contracts. And finally, recently, as recently as a couple of weeks ago, when I was first talking about governance, there was a long tweet storm by Elad Verben about how, straight voting on lots of little parameters isn't actually an effective structure for governance for smart contracts, and you'd really like something that was a little more executive, that some set of executives could make decisions for a system, and the people that had tokens would be helping to determine what that executive function was and who was going to execute it and what their accountability was. Those are all really valuable ideas. The key thing is that governance is still evolving. There's a bunch of good ideas. We know there are some not so good ideas that we would like to protect against or prevent, but we need to understand. And as we build these systems, there's clearly a richness, hundreds of years of people thinking hard about this because it mattered. And as we're building systems that matter, that control billions of dollars, all of those issues come up. We should really be in a position to both tap into that historical knowledge and also evolve it quickly for our unique circumstance of online smart contracts that can really enforce certain cooperation arrangements between parties. And this is what we're going to talk about a bunch here. Okay. So let me say just a little bit about Agwork for the tail of users that haven't seen the other talks in this conference. We are focused right now on DeFi, but it is a general purpose platform. But our focus really is accelerating DeFi development. And we do that by enabling this composition and pluggability. So it's a layer 1 public blockchain, will come out in 2021. We start with the fast finality of Tendermint, battle-tested consensus model, though we're largely agnostic and will be able to evolve forward as improvements are made. We have predictable gas economics, which I'm not going to go into here. A familiar programming model, so you can build smart contracts in JavaScript, and many of you here in the hackathon are indeed building smart contracts in JavaScript, in a secure version of JavaScript, where the model of separating things into objects gives a bunch of advantages, particularly around compositionality and around risk partitioning. So what do I mean by that? 15 years ago, there was a JavaScript, and experts could do some cool things in user interfaces, and we were starting to get a little bit of interactivity and some smart applications and that sort of thing. But React a few years ago came out, and with it or Vue or Svelte or any number of different object frameworks, beginning developers in a month or two can make vastly superior, more safer, more powerful, more responsive, working on more platforms, whizzier graphics, all those things than experts could 15 years ago. And that's because they're able to build using components that those same experts produce to capture their knowledge into some object that's reusable. And that's not copy the code, deeply understand it, muck with it a little bit and hope you didn't break it and glom it all together, which is the code copying, remixing that you currently see in the Ethereum space. That's grab a component, add some parameters, and use it as is. And it turns out measurements show that for most web applications, this is on GitHub, 97% of the code comes from components that were brought in and used with mere parameterization, instantiated in various ways and plugged together. And it's 3%, which is your comparative advantage, the value you bring to deliver an app that has the part that you want to focus on. And it's important that we get to the point in smart contracts and in the world of DeFi that we're not having to build everything from scratch, but it can instead build on top of other components. Now, it's also important that not be done by this source code remixing. Very exciting that Uni came out with a token where they were able to take this whole rapid development is they were able to go from years of development, for even months, down to weeks of development, where they took the compound governance token, combined it with Uniswap to produce a governance token for Uniswap that had a lot of value for people. That worked great, but that worked great because it was a special circumstance, right? The governance contract happened to be exactly what they needed. They had expert knowledge from behind the scenes of exactly how it worked and exactly how it needed to be glued very carefully together. And so they could safely make what few changes they needed to fit it all in. And that was a great success. The problem is, it's not always a great success. When you work that way, they had a lot of advantages. Other folks, dforce's lendf.me, did the same thing. They took the compound source code, they took their application, they put it together, they deployed something, and the impedance mismatch there, as a result, they lost $25 million in minutes with no recourse, right? These are, the 50-50 is not a great number for success versus losing a lot of money. Right? That's not the way to be able to rapidly compose and produce new abstractions, new applications, leveraging the value that other people created. Much better would be able to take a governance module, parameterize it with a few things, and plug it together directly so that this separate governance contract would in fact have the same behavior would validate its same security audits, would be predictable, and people would understand it, and it would solve your problems. We're going to talk about some about how to do that. And then finally, the Agoric platform is built for DeFi, where it has the DeFi elements all the way through. So several of the reusable components that I'll talk about in a few minutes are integral to the system, from the bottom to the top. And we'll talk a little bit about that, including simple composition of both financial components and governance components. Okay. So what are the layers of the stack? I'll start at the bottom. That is, as I said, the consensus layer, where the reward elements are not just the Cosmos ones, but they're actually mixed in with a smart contract and able to use the same smart contracting richness of the rest of the system. Above that is the Agoric swing set, the Agoric VM environment that allows us to, on the same platform, execute in safe compartments smart contracts written in JavaScript, all securely communicating with each other, and also securely communicating with machines that are part of this Agoric distributed ecosystem, machines offline that are either running your wallet or running an application service in the cloud, and they get to communicate with the same JavaScript asynchronous messaging communication architecture that literally millions of programmers are familiar with in one form or another in the JavaScript ecosystem. And then now that's the language level. Above that, everything is just written in familiar programming language, right? In this JavaScript environment. So ERTP, the Electronic Rights Transfer Protocol, is a set of APIs for talking about digital assets. A set of APIs for talking about accounts, purses, payments, transfers, all those sorts of things. I'll show some of those. NFTs, fungible tokens, whatever it is, and on top of which people can build the rest of the dApps they want to be able to build. Those are sort of the starting pieces, like React's components and render functions. Zoe is then the framework for actually deploying smart contracts into and enabling nice coordination and cooperation. Whoops. And then finally, above that, we build user-defined Legos. So we user-defined dApps and contracts, including their Legos. So the ERTP Legos, and there are Legos throughout the whole system. Purses, payments, fungible tokens are in ERTP, as is a faucet, that like a few days ago, Kate showed the implementation of a faucet abstraction that you can get fungible tokens, and an NFT sales abstraction that showed the use of NFTs almost as easily. And so those are all parts of sort of the basic toolkit on which then are built richer ones. So atomic swap, simple exchange, which is an order book, auctions, automated market makers, all of those are able to work across any of the set of digital assets that were created, fungible and non-fungible. They're able to use those inside, so I can have an automated market maker in terms of my newly defined liquidity token or governance token or whatever, turn around and be able to sell it and so forth. On the right column, there are additional ones that are, I won't say they're advanced ones, but they're not as familiar. So a covered call abstraction lets you provide to someone the right to buy my underlying asset, whether it's a non-fungible token, a baseball card, access to an auction, or just remoted atoms from the Cosmos hub. I can give you the right to buy that for a particular price. And then we use that inside the OTC desk, so that right to buy it is now represented as a quote in the over-the-counter trading desk application, dApp. Call spreads, there was a presentation on earlier this week on how to use call spreads to achieve many of the kinds of derivative abstractions like puts, calls, spreads, binaries, prediction markets, and so forth, using this same underlying DeFi parameterized in just a few ways. The loan contract I'll talk a little bit more about, and of course, voting is a reusable abstraction. So, finally, of course, in this contract, in this environment, we have Oracle Legos in terms of being able to pull in Chainlink oracles as Oracle nodes under an Oracle contract, glom several Oracle nodes together with an aggregator and present that all as a price feed in the price authority, or access it directly through the Oracle contract to drive lower level and richer functionality of the underlying Chainlink oracles. Okay, so finally, let me start talking about composition. So to build a loan, so this was the loan case, which is one of the smart contracts that we built, one of the dapps we built that uses the Oracle abstractions underneath, so that there's a set of collateral. I take out a stable coin loan against that, and if the price of that collateral falls enough, it'll automatically be liquidated against a automated market maker. And so the determination of whether it needs liquidation happens against a current price feed. So it's constructed where you're taking a loan and we agree that, you know, you're posting some off-chain asset like ETH. And if the price of ETH, according to this particular Chainlink Oracle, falls below a certain price, our loans will be liquidated. And so they will be liquidated against a particular AMM, which is the one that, for example, is part of the Agoric standard environment execution infrastructure. And so finally, every loan will be instantiated. You know, each time I take a loan, I get a new loan contract that knows which AMM to liquidate on and which price feed to use. And each one of those is a separate contract. So they're not vulnerable to each other. They don't share any assets in common. They just, you know, I just instantiate these lightweight contracts once for each loan, and they can each independently liquidate and then evaporate once they're done, or if I pay them off. And that's on a price-based notification tied into our org. Okay, so that's an example of plugging some of these components where I got to Kate got to write the loan contract using the existing AMM and using the existing price feeds that pulled in the current Chainlink aggregation. And as people add more, you know, pooled pay for prices or any of these other aggregations, it could be one could deploy loans that use that. And so the nice thing is the loan doesn't care. The loan doesn't care about which particular price feed it's using. The loan provider constructed that, sold you a loan where you agreed which price feed you were going to use. That's the loan you got. And there was agreement on the underlying components that would be plugged in for your loan. Okay, so I'm now going to go into some code. We'll look at the structure of the contract. Every contract starts with is just a JavaScript module that implements a start function. It takes ZCF is the access to the underlying services for that contract. And then it does some setup, and then has, for each kind of offer that might participate in this, our system is in terms of offers. For each kind of participant, there is an offer handler. So in an auction, I've got the seller and I've got bidders. So there'd be an offer handler for the seller, there'd be an offer handler for bidders. And then for each of those participants, I'm going to make an invitation to come take a seat at the table. That's why we call this argument to the offer handler a seat, is you get invited to take a seat at the table for this contract, and that seat is how the handler will figure out what did you pay, you know, what are you currently offering, what do you want for it, and engage in the behavior in response to your request to participate in this particular contract. There is then a creator facet, which is the object that will be handed back to the creator of this contract so they can start it off. So they can create the initial invitations and hand them out, so they can go and, you know, create a seller seat and sell it on some other market or whatever it is. And then finally, that gets returned. Creator facet is one of the main things, but you'll see a few others like a public facet that would then be available to any participant in the market and a few other options. But that's the core structure of it. So now let's look at some content like this. Let me bring up I guess it would help if it was on the right window here. There we go. And let me zoom this in a little bit. Okay, so this is a voting contract. If I come down here, let's collapse. So you can see there is a start method. I will go to the bottom, and you can see that I return a creator facet. So let me bring up the outline here. And note that this is just standard, the standard VS Code where each of these operations, you know, has type information. I get command completion. Whoops, it would help if I type correctly. Right, make invitation, you know, which has all the arguments, etc. Okay, so you can see here's the make invitation. It takes a vote handler. I can, you know, follow that up using my shortcut keys all to the vote handler. It tells me what all the arguments are, all the things you expect out of a normal development environment. Okay, so what does this election do? Well, it starts with its setup where it has a, you know, let's open is the election open? It has a map from voter seats to their responses. And finally, there is the handler, as I mentioned. So what does the handler have? Well, it gives the user a object when the user accepts the invite to sit at the table for this vote. That invokes this handler, and they are returned this object, which will be an object that lets them vote. So I sat at the table, I get back an object. Now it's got a vote button where I can pass in yes or no. Okay, and that's what it takes to do voting. But the authority, the weight of my vote, is tied to the assets that I provided in my offer here. So this vote handler gets invoked when the user makes an offer. Their offer is, I will lock up, 30,000 tokens here if you give me back a vote handler. And as soon as I exit and get my 30,000 tokens back, my vote stops counting. So I'd better leave it there for the duration of the vote. The creator facet, the person who created this vote, has an operation which is to close an election, where they can then tally the set of yes votes and no votes, and returned overall what did this vote finish, right? What's the value at the end of the vote. Now, I'm not showing here the elaboration of this, where it then also has the function that will be invoked, and maybe it does. Function that will be invoked when the vote completes. I'll show you that in a moment. But that's the basic structure of this. And there's test cases and various things that glue it all together, and you can run automated tests on this stuff. And that's how we build components and how we have reusable components. Now let me show a little bit about how we would use this in the system. So that's just our quick flash of real code, and that's the simplest voting contract we can have. Let's talk about where we go from here. So that baked in a couple of key choices there. And I believe, by the way, my talk will run a little long, so I apologize, but I think it's worth hitting all of these points rather than rushing it here. So that, so first is what is the voting authority? In this particular case, on what basis do you vote? Here, it escrowed tokens, it escrowed collateral, and that would be whatever that vote was constructed to require. It's not just that I stuck random tokens in. That vote had a particular underlying asset that it was looking for, that is the thing that you would escrow in the offer. And so I present those tokens, and that's escrowed with the vote. But there are others. It could be, for the underlying staking token, for the underlying staking system, I don't want each vote to have to lock up my token. I just want to refer to the staking token and get essentially an affidavit that says, yep, he's got 40,000 tokens stored, right? So what will get presented is not the tokens directly, but rather an affidavit from the trusted source, which is itself an NFT in the system. Or maybe it's a fungible token in the system that can be used by a particular voting instrument. And so it's easy to build that in the same libraries that these original systems were built in. So that's where we get state token vouching. But the same mechanism could be used for the lockup of tokens inside of your smart contract that that is the liquidity token for your AMM or whatever it is. Then there's what's the decision, right? In this particular case, well, how is the decision made for a particular voting? The obvious one is the voting is, Dean decides, I click on yes or no, and that's the only thing that happens. Obviously, in our case, we had other choices. It was a simple majority where it was going to return, yes, 1, and here's its percentage. But it could be that it converts to using an oracle. For a given governance decision, there may or may not be a vote. It might be that we moved from voting to, we're not going to vote on the interest rate required by the bank. We're going to go and get an oracle from Chainlink for what's LIBOR today, and it'll be LIBOR plus 1% or minus 1%, whatever it is, right? And so switching from voting to some other automated smart contract, that's still governance. And the nice thing is your underlying smart contract doesn't care. You're going to plug in something that says, here's the governance today. We decided by running the smart contract that plugged it in. And finally, when is it done, right? In this case, there was the close election operation that the operator of the governance token got to do. In other people's cases, it might be some particular day in November. Which particular day is yet to be determined, but some particular day in November. Right? It might be, so that would be a time-based one. It might be periodic, where we're going to have the same vote every month on what's the change to the governance token or whatever it is. And so these are all options for governance where, every particular combination of choices is important and valuable and might be appropriate for some smart contract. Okay, So what is that? What might that concretely look like? That loan example that I mentioned, right? It's a smart contract. It's got some term which is the margin required. So let's say you've got to have 120% of collateral to cover your loan. Otherwise, it's automatically going to liquidate. So that means somewhere there is a, where 120% is the starting number. So somewhere in that loan contract is if the collateral to loan ratio is less than the margin required, is less than 120%, then we're going to liquidate the loan. Now, we're not going to talk about that. In our loan contract, the liquidation, it just goes and sells it on a market that it was told to sell it on, and the loan contract itself doesn't have to know what that was. It got constructed with it and parameterized with it. So your loan versus my loan might liquidate in different places, right? And then it sets up the margin required. Well, how are we going to change that? The nice thing is this is JavaScript. We've got all sorts of way to change it, and there's millions of programmers that will understand how to put that together, right? So a simple update function, a simple object that gets exported from the loan contract and provided into governance is now something that the governance contract, once it decides, could go ahead and call this to say, here's the new margin. So let's say I want to update it to 125% from 120%. Because we're in a volatile time of the market, or 110% because everything's sailing smooth, and or 102% because we realize that both of these are stable coins and we're getting a loan in one stable coin from another stable coin. All of those are entirely plausible. The loan contract doesn't care; it just needs to be told what the margin is. But that's pretty raw. I could change it to 80%. That seems like a bad idea. So what if so the nice thing is the loan contract could build in particular requirements where it's doing an assert here that, yeah, you can't have 80%. You can have 101%, right? But you can't have 80%. So you can't go below a certain amount. And now no matter what governance decides, it'll turn around and try and apply it. And the contract is providing its users assurance of the limits of that number independent of governance, right? That's really nice. Or independent of the simple parameter governance. Obviously, there might be an upgrade the contract, what have you. But that means this mechanism has these nice limits built in. And so now that's the mechanism by which the contract is enabling arbitrary governance process to set a new margin requirement. Okay, so then what does that governance process look like? Excuse me. So the question is, do we raise the MMR to 125%? The vote is start an instance of that majority vote installation, right? In Agoric, when you've got a smart contract, it is installed once, and that's making the source code be something that has has a specific object on chain that you can start to add, security for, security assertions for, and various things to provide people assurance that if you're running this source code, you're getting the behavior you expect. So in this case, it's instantiating a particular installation that we know to be a majority vote installation of source code. And it's instantiating that where the asset that wants, and that's the kind of thing that I showed you the smart contract before. The asset that it wants is the governance token. It wants you to provide tokens that the issuer of governance tokens believes it issued. And there may be other terms. I'll talk about that in a little bit. And so now it's going to publish that by taking that vote contract, that new lightweight contract, and making it available on all the votes, right? That's just a JavaScript object that has a notifier that anyone who is interested will get notified, and their contracts will wake up and they can participate, or their off-chain machines will get notified and wake up and be able to participate, right? And then once that vote happens, it's going to asynchronously request the decision, and that decision is a promise that it will get for the decision only once the vote is completed, right? And so now this governance process just awaits for that vote, and that might be 2 days, that might be a month, whatever it is, that just sits there and waits for the vote. And once the vote happens, if the decision was yes, it then invokes that MMR set function that we got through the terms, which I didn't show here, but we talked about it in the previous slide here, that MMR set function, and calls it with 125, which will pass the assertion, and so the number will get updated, right? So that's how it gets wired together for this particular installation of voting. And the nice thing is my overall governance of this long-term loan contract has access to the update margin function, but it might be running a vote every week to decide what the margin is for a particular asset. or it might be any number of different mechanisms. The nice thing is this loan contract doesn't know. It exported this object to governance. It was instantiated saying, this is the process that's going to govern you. And that governance thing is going to instantiate as many votes as it wants. The loan contract doesn't need to know about that. It just gets updated as appropriate as things happen. And that's where pluggable mechanisms start to come in, where any one of these might be, right now we're voting based on majority. The governance process then decides it wants to use a different process, supermajority, an electorate, whatever it is. So that lets us do a fundamental thing of separating the concerns. We build large-scale systems, we engineer large-scale systems, and we evolve interesting, complex relationships across multiple cooperative parties by separating the concerns. And that doesn't mean sweep a concern under the rug. That doesn't mean ignoring, the volatility and cost of execution or any of that stuff. It means separating them out. So here, the decision mechanism was the vote, and we could use different decision mechanisms, right? The change to make is represented by the updater, and the nice thing is the same voting mechanism could be used with different updaters to update different parameters. And the triggers are managed. The decision of when to vote, how to vote, what the parameters are embodied in a contract itself, right? In this particular thing, right? These are separate smart contracts, independently instantiated, where you can evolve new ones, you can change over time. Governance could choose to, in the future, to use a voting contract for future voting or for specific types of voting that didn't exist when the governance contract was created. And so you really get to put these different concerns in different contracts such that you can evolve them over time or plug together different arrangements for different purposes. So a lot of that then brings you to that whole meta governance thing, where the policy and process for a decision could change over time, where we go from directly voting on parameters to changing the governance so we're voting on a DAO that will drive it, and that DAO is funded by some other token. Or moving from the dictator decides or a set of small multi-sig keys decide to transitioning to a DAO or to a committee and extending that multi-sig. So that's that changing of that decision mechanism, and change the triggers, right? We can go from voting every week on a periodic basis to voting when the market changes just enough. And that can all be automated in the governance contract, where it sets up, and originally it's got a periodic clock, and now it's watching, the price oracle for the price to change on some underlying external oracle coming in from, Chainlink's gold price or whatever it is, right? So that lets us, again, put these different concerns, including the meta concerns about the process, into different contracts and reuse them. So if I build a contract for my particular application, you can pick that up and use it to yours, not by copying the code, but by simply parameterizing it to use your governance token rather than mine. And so, and this is almost my last slide. So what that really means is, it's not that one size fits all, it's that one size fits many. That's what reuse is all about, right? Where many of the policies that I talked about, many of the strategies are reusable, and especially the ones that we will be building for the Agoric economy, governing which currencies will be used in our stablecoin mechanism, governing proposals applied to the chain, staking parameters, staking derivatives parameters, all those kinds of things are affected by governance. All the contracts for governance will be exactly these kinds of plugins that you will be able to use for your smart contracts. All the ones that you build now for the apps that you're building for the hackathon, please make sure that they're structured as reusable, because then you can use them, adapt them, replace them in your own contract, and other people can build on what you've got. Having said that, governance is very early, right? We've got innovations all the time. Some of them are a big deal, but we've got a lot more to come as we evolve governance and adapt it to particular purposes, as people come out with new DeFi apps and new dapps that have different governance requirements. It's a very exciting time in governance, and what's important is that you be able to do that in a way that can evolve quickly. One, if it's built inside your contract, if the loan knew exactly how it was going to be governed, then tomorrow that loan is obsolete and we have to go do a whole new one. Right? Whereas if it's pluggable, I can reuse the same validated, reviewed, battle-tested loan contract with a different governance agreement that with limited control over the parameters of that loan. And therefore, governance must be extensible, right? We're just at the beginning. We've got a lot more to build and a lot more to want to be able to reuse with each other. So as much as we are building governance tokens, we know it's got to evolve, and we know much of the evolution is with developers like yourself, is with the millions of developers out there that we'll gradually attract onto these blockchain systems, because now in our system, they can build with the language they're familiar with and in a model they're familiar with. And so I'm going to be as much a customer of the governance innovation that everyone is enabled to do, as well as obviously the DeFi innovation, as I am a provider. And I'm very excited that we'll be working together on these kinds of things. So thank you very much. And please, help us make DeFi even more exciting and, yeah, a lot less dangerous.
Thank you, Dean. So with that, it looks like most questions likely are going to come in over Discord, so happy to engage async. Dean, I'm going to take you down, and we will roll straight into the next presentation.
Thank you very much.